So I'm here with a friend, Scott Harkey. I've asked him to help us with some questions we have for some gaps in the program about technology, specifically legacy technology. Scott, would you mind just introducing yourself to the faculty?
Yeah, absolutely. So, hey, Scott Harkey. I am currently the head of kind of go-to-market for an IT services firm called Endava, based in Charlotte, North Carolina. Have a history in banking. Spent about 15 years at a combination of the two big banks, and then helped start a consulting company, IT services consulting company, and been doing that the last 7-8 years. So
Great.
that's me.
Thank you so much. So Scott, we briefly chatted right before we hit record, and what I was explaining was that in putting together the curriculum for the faculty and helping them to sort of develop their own digital payments expertise, I was able to find some good content about next gen and, API forward thinking. But what I'm more interested in right now is what's missing. And so I'm curious what we can tell them about more legacy systems, legacy languages, legacy architecture in digital payments, and what they need to be focused on and what they should be teaching.
Yeah, well, I'll give it a shot, at least hitting the areas that are most familiar to me. I think of it as a couple of key kind of changes that have happened, and then the modern tech that we have that's driving a lot of payments and financial services infrastructures build off of some of these kind of changes or shifts. So the first one was around mainframe to cloud, right? So a lot of legacy technology was built off of mainframe,
Right.
which really just means it was centralized, right? It was fixed in capacity. It was hard to turn on and off. It was, kind of single points of failure, if you will. And as that evolved, it went from, that to being distributed. So it was still mainframe, still sitting on servers in places, but it was replicated in multiple servers, which added a layer of, at least it wasn't a single fail point. But it created a lot of challenges around, as you were deploying software, as you were building things, you had to deploy it in multiple places and you had to make sure it all stayed in sync. So it kind of created its own set of challenges.
Got it. What year are we talking like around at this time?
Oh, that's a good question. I think probably the move to distributed was probably, I would say, mid 90s or so.
Okay.
I don't know if I've got that exactly right. Somewhere in the decade between the mid 90s to early 2000s.
Okay.
And then the third kind of phase was in moving into cloud. And there's really kind of two pieces of that. But the move into cloud was probably, really in kind of meaningful way in late 2019 or 2009, 2010-ish timeframe is with the first kind of start of that wave, I think. And it's taken quite a while to build out into getting into financial services specifically. So a lot of other industries adopted it earlier, and there's a lot more momentum. But even now, financial services is much slower in adoption of cloud technology because of perceived risk of that. There's a lot of controls in financial services that kind of appear to be not in alignment with cloud infrastructure. And a really simple, basic example is things like most banks have kind of security protocol that say any new vendor that they sign up, they have to be allowed to physically inspect wherever they keep data, right? And a lot of the fintechs use Amazon Web Services or another cloud provider where they don't have access to where they physically keep data.
Right.
And so it just goes to show that from a bank policy perspective, like they're still catching up with the idea that like, the data could be distributed in all these different data centers, and having like actual access to it is not really relevant, right? It's more about where the security controls in place.
Okay.
But I think that, so a lot of infrastructure, especially in banks, and even kind of more broadly in payments companies and financial services companies, does still rely on a component of hardware-based, mainframe-based infrastructure. Especially in things that hook into the core payment system. So things that hook into ACH, that hook into Fedwire, that hook into these, underlying systems of money movement in the US, especially. they require a physical connection in a lot of cases. So if you take, some of those specific payment rails, you have to have a physical location co-located in the same building as their connection.
Wow.
And it's got to be kind of sitting on the same server with so it's got to be physical proximity to theirs to basically ensure that a nefarious third party can't get in the middle somewhere, right? So
And in terms of
uh,
fixing problems with that kind of a system, are we talking about, I'm using the word legacy, but it's out of my depth in terms of technology, legacy languages, legacy coding capabilities as well?
yeah, so a couple of things. So yeah, so the language used, the programming languages used on a lot of the mainframe technology are different for the most part. So the kind of old school one and it's gotten a resurgence just as a lot of the modernization work has happened is COBOL. So COBOL is a very old programming language built specifically for coding, or got popular around coding based on mainframes. It went, no one's coded anything modern in COBOL for probably 15 years, if not longer. But as modernization is happening and as companies are going and looking at how do we take all that we have and either fix it, attach it to something new, or build it, transition it to a whole new thing, they're finding the need for people that understand COBOL because they have to kind of pick it apart, right? You have to understand well, how does it actually work? And to do that, you have to be able to read the programming language.
Right.
And so there's actually a big kind of gap in the market right now with people that know COBOL, because it's not being taught anymore, right? It's not a language that's taught in schools anymore, at least unless you seek it out. And again, it wouldn't have any real use in modern software development.
Right.
It's only in these kind of legacy
Integrations and things like that. Right.
Yeah.
Right. That's interesting. So have you hired people with COBOL knowledge lately? And if so, are they older folks or?
Yeah, so it tends to be older people, in the sense that people that learned it when it was a more popular programming language. I don't know that we've hired people especially for having COBOL knowledge as much as it's kind of when we find them in the organization, then it's
Right.
almost like all right, well now we need you over here, right?
Right.
Again, because the type of work is it's not consistent, right? Like
Okay.
you'll stumble into projects where you need that experience or that expertise, and so then you need to find it. But it's
Okay.
not a thing where you're just constantly needing that skill set. So it tends
Got
to
it.
be a thing that is a little more on the fringes. As an individual, you can make quite a bit of money off of focusing on COBOL and going and finding those opportunities,
Right.
because it is in really high demand. But as a services organization, it tends to be, something it will be person with another set of development skills.
Right.
And
Who
they
happens to
happen to
also.
also know COBOL because they learned it, earlier in their career.
Great. Got it. That's so perfect for exactly what I was hoping to help these folks learn. And in terms of putting together, so they're going to be doing a lot of experiential learning with their students. They're working right now with a program called Uncork, which is a no code application. And that's really more centered around, I think, an architecture perspective, right? Helping the students understand the flow of a certain transaction and maybe put together a program. And the students love it and they're much quicker on it than I would be, for example, and they're taking to it really well. When it comes to things like architecture and the stuff that you're seeing, are you finding it to be more, again, more legacy, or is it, taking a new leapfrog approach?
Yeah, that is the thing that very much is consistently using modern kind of tools and software. I think what the shift to cloud did was not just change like how software gets like physically stored. It also changed the scalability of software in a way that's changed the way people build things, right? So historically, deploying software in a mainframe environment, you could spend weeks or even months getting a physical server set up with all the right kind of environment and everything on it to even be able to put a program on it, right? With all the modern cloud-based infrastructure, you can spin up the equivalent of a server, have it completely configured, and have it ready to go to install, to start building on, start developing on within seconds. I mean, in less than a minute. And it's a huge difference in terms of how programmers work, because now instead of, being really careful about being ready for that step, because it's this big planning thing and it involves all these other people in the organization, it's, you have an idea. Again, if you have the skill set, you can quickly spin up an AWS instance, you can get going right away, you can deploy code publicly, and so what's that changed is the way applications get built tend to be more modular now. So it tend to be architected in a way that allows for multiple people to be working on a similar thing and quickly deploy code that kind of touches a piece of it, but doesn't force the whole thing to kind of be rebuilt. So from a coding perspective, the legacy coding languages were, you had to do something called compile them, right? And that you would write software and then you had to run it through a compiler that would basically get it ready to run. And any error in the process would just make the whole thing fail, right?
Got it.
And then you would then have to dissect all that. And again, you'd spend forever trying to make it work. With modern programming languages, you don't compile, their runtime. So you build something, and as you're writing it, you can instantly see whether it's going to work or not.
Right.
And so it changes the development cycle in a way that you can have multiple people working on a very, very similar thing or piece of functionality. You can all be deploying code simultaneously. You can spin up things, down things, add capacity, pull back capacity. And so modern application architecture kind of takes advantage of that by the language often used is moving from monolithic applications to kind of component-based applications. So, and there are different, programming languages and frameworks that kind of align to that. But fundamentally, it's that instead of thinking of, if you had a problem you're trying to solve and you were going to build a piece of software for it, the legacy approach would be building a singular piece of software that solves all those use cases and does all the things.
Right.
Modern approach should be you break that down into whether it's the users or the set of use cases or similar set of experiences, whatever, depends on what the business is, but you break it down into modules. And so, an example in the payment space would be, again, historically, something like a payment hub would be a single application that is all the code. The modern version would be you build a module for the outbound interfaces, so the actual connections into third-party networks, and you build another module for data translation that takes the data fields and remaps them, and you build another model for orchestration, and it's what determines the actual flow. So you take it, you break it down into these individual components, and then you build those. Again, you can have multiple people working on them separately,
Right.
Scale them, et cetera, et cetera. So that's the biggest change in kind of modern architecture, is moving from a monolithic approach to a more modular component-based approach to software design.
That's fantastic and so helpful. And so the last question, and I'm not going to keep you too much longer, but I really appreciate your time.
Sure.
For everyone who's watching this later on, this is like the end of Friday before a holiday weekend. So I really appreciate it. Is there anything that, if you had a wish list that you were wishing students in this space were learning before they got to you? Can you think of anything that we could, tell these faculty members?
Yeah, for sure. So we have a lot of we do a lot of college hiring, and so we've had a lot of experience with people that have come out of really good schools and are really smart. But the thing we consistently see is often schools teach students the specifics of whether it's a programming language or it's how something works, or it's the knowledge of this is systematic knowledge, right? It's like, here's how this thing works or is designed, or this set of information. What we consistently find people lacking in is problem solving. It's forget how you do it, step back from it and think about how would you actually approach solving the problem. So in software, the kind of best way to articulate it is, a lot of times the students will get programming assignments or something where they're getting tested on kind of, do they understand how to structure the code, or do they understand how to write, use a particular set of tools to solve the problem. But what it doesn't necessarily teach them is why is that the thing you're solving in the first place, right?
Right.
Why that, right? And is that the best answer to do it, or is there another way to do it? And how do you know whether it's the best answer, right? So how do how do you structure thinking around solving the bigger problem, as opposed to like, do you know how to code in Java, right?
So I would assume that there's also a diagnostic piece to it, right? It would be looking at something and figuring out what the problem is,
Yeah, it's the
right?
thought process, right?
Yeah,
It's teaching them to step back from it and say, like, again, forget the actual tool I use to solve the problem. Structure my thinking around it of like, have I defined my objectives? Do I understand who the stakeholders are? Do I understand the in-state experience I'm trying to create? Like, then I can solve the problem. And that's the biggest gap we see, because we get a lot of really smart people who can code things or do architecture or whatever the skill set is. But the minute we put them in a client engagement, the client doesn't speak that way, right? The client's
right,
saying, I need a thing that does this. And they're like, well, I can code, but like, I don't know how to take that and turn it into an architecture, or turn it into an actual like project plan, or turn it into an approach of how I would solve it.
that's
And so I
fantastic
really think in these
information.
types of programs, the more of that we can do, the more it gets people ready for the workforce, where that's what you're doing. Like, very rarely, well, most people don't even want the job of like, for me to come and say, hey, like, code this thing to this exact spec. It's like, nah, that's not really the job.
Right,
The job is
right.
more often, we have a problem. How do we solve the problem? We need technology to solve the problem, but we first got to get to structuring the problem and the solution before we get to the tech.
Yep, I totally get it. I mean, one of the things we're trying to achieve with this program is we're trying to get students to come out of school with that 3 to 5 years of experience under their belt before they walk in your door, so that they know the stakeholders, they understand the system, they speak the payments language, digital payments language, so that if you're trying to solve a problem in a peer-to-peer situation versus a card situation, at least they know they have a starting basis of knowledge, as
Yeah.
opposed to you having to train them on the job. That's what, I think that's
Yeah.
also part of what you're talking about.
Oh, for sure, for sure. I mean, I think in the payment space specifically, there's so much context to these things that if you don't have it, or you don't understand how the system works, then yeah, it takes a while to kind of get up to speed on that and to teach people that. We often don't hire junior payments people because of how long it takes to get them up to speed just on the fundamentals of how the system works.
Right,
So
right.
totally agree in the value of that knowledge, and again, just serving as a baseline for the bigger picture problems or thinking, right?
That's it. That's what we're doing. Thank you so much, Scott. I appreciate your time. I know the faculty does as well. This has been great. So it's exactly what I was hoping we would get. So I really appreciate
Awesome.
it. Thank
Yeah,
you.
absolutely. Happy to help, and just let me know if I can help. I have a passion around, so we talked about it before, right? Some of the education and building programs and all kinds of different things. So always happy to help. Just let me know.
Absolutely. Thank you. Yeah, I have a feeling we'll be calling on you some more. So thank you so much.
Absolutely.